All right, guys. I just did this video, but I counted wrong, so we're doing it again. We're doing 4.6 notes on area and perimeter in the coordinate plane, and we're going to be classifying some figures as well. I'm not going to write on the blanks because it's too much zooming around. I'm just going to zoom in, and then we'll draw some arrows. It's going to be fine. Okay. So here's my first cute little picture. Right now we can see that the base of this triangle is 6 units. But I don't really know what this side is, and I don't know what this side is. Now, if I had a right triangle, I would be able to use the Pythagorean theorem and find one of those sides. So that's what I'm going to do. I'm going to make a little right triangle by dropping a perpendicular from my vertex and making this fun little orange triangle. Okay, I've got a horizontal and a vertical side, so I know those are perpendicular. Now this leg is 3 units, and this other leg is 1, 2, 3, 4, 5 units. That's what I messed up in the video before. I counted it as 4 because I was going too fast. Okay, so what we're going to do is use the Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. You can identify the hypotenuse because it's the longest side and it's always opposite the right angle. Okay, that's our c. So I'm going to make my a 3 and my b 5. And I don't know my c yet. So I do know that 3 squared is 9, 5 squared is 25, 9 and 25 make 34. So my c squared is 34. Now I don't want c squared, I just want c. So I'm going to have to take the square root to undo the squaring on both sides. So the solution, there are 2 solutions to this equation. One is positive, the other one is negative. Because we are after a length, we do not want the negative one, we just want the positive one. So our c is going to be the square root of 34, the positive one. Okay, so that is this guy right here. Now if I look at the other side of my big triangle, I can do the same thing. Here is a leg of 3 and another leg of 5, but if I did 3 and 5 again, that would be the same math, and I would get the square root of 34 again. So if we've already done that math, we don't have to do it again. But what we need to notice is that those sides, because they are the same measure, the definition of congruent says that they are congruent, so I can mark them as congruent. Now that I know that I have 2 sides congruent, I know that this is an isosceles triangle. And I can tell that all of its angles are less than 90 degrees, so I know that he's also acute. Okay, let's find his perimeter. For the perimeter, we have to add all the sides. So I have one side of 6, and then I have a side that's square root of 34, That was a weird 4. And another side that's square root of 34. So if you're keeping up, I have two sides that are square root of 34. So I can simplify this expression as b equals 6 plus 2 square roots of 34. I can combine them and add their coefficients because they're like terms. Just like if I had x plus x, I would get 2 x's. Okay, if I have root 34 plus root 34, I get 2 root 34. And this is my answer, 6 plus 2 root 34 units. Okay, that's for the perimeter. All right, for my area, remember that a triangle is really just half of a rectangle. So the area for a triangle is 1/2 the base times the height. Okay, so for my area, my base and my height have to be perpendicular. So base must be perpendicular to height. So when you're picking in your base and your height, make sure that they are perpendicular to each other, that they are 90 degrees. So area equals 1/2. My base is the 6. And my height is the 5 that's perpendicular to the 6. Here's my height of 5. Okay, half of 6 is 3. 3 times 5 is 15. So my area is 15 units squared. They have to be units squared because area is not linear, it's squared. Okay, that'll do it for number 1. Let's do number 2. Okay, if you look at, actually it's 1B. If you look at 1B, it's basically just like half of the one that we just did. You know what I mean? Like they already gave us one of those little cute right triangles. So thank you. I know that these are perpendicular because this is horizontal. It has a slope of 0. And this side is vertical. It has an undefined slope. Whoops, not vertical, vertical. Okay, that should not have been hard, but I made it hard. It's fine. All right, so this side down here is 1, 2, 3, 4, 5, 6. Counting is hard. We can do it. It's fine. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, I have my 2 little legs. Okay, and I can use my little legs to find my C value, my hypotenuse. So my 6 squared plus my 8 squared gives me my C squared. 6 squared is 36. 8 squared is 64. 36 and 64 make 100. But I do not want C squared. I want just C. I don't know why I made that so close. I want just C, so I have to undo the squaring by taking the square root. So I do that to both sides. There's a positive solution and a negative solution, but we only want the positive one. So the positive square root of 100 is 10, and that is my C. So my perimeter, I have to add all the sides. For my perimeter, I have 6 plus 8 plus 10. That gives me 24 units. Okay, remember that a triangle is just half of a rectangle. So I can just do base times height and then take half of it, right? Okay, so my area for my triangle is 1/2 times my base times my height, which is 1/2 times my base is 6, my height is 8. Remember that the base must be perpendicular to the height. That's a rule. Half of 6 is 3. 3 times 8 is 24 units squared. Okay, we've been talking about this right angle in our triangle. So we know that this is a right triangle. Also, I hope you can tell that all three of these sides have a different length. Okay, so it's not equilateral, it's not isosceles, it is scalene. Okay, we're going to zoom in a little bit on this guy. This is obviously not a triangle. Now we have a quadrilateral, but we can use the same trick. So what we can do is find a little couple little triangles inside this quadrilateral and use the Pythagorean theorem on them. So that's what we're going to do. You see this guy right here. That is a little baby right triangle. Okay, so we can use that right triangle to find this C, because that C is that little baby right triangle's hypotenuse. So here's a leg of 1, and here's a leg of 4. So 1 squared plus 4 squared equals C squared. 1 squared is 1, 4 squared is 16, 1 plus 16 is 17. I don't want C squared, I want to take the square root. There are two solutions, one positive, one negative. I don't want the negative one because I'm after a length. Lengths are always positive. So I want the positive root 17. So that cute little side is root 17. 17 is not a perfect square, so it doesn't simplify. It also has no perfect square factors other than 1, so it's already simplified. There's nothing we can do to it. We just got to leave it be its nasty little self. Okay, now let's do the same trick over here. Draw up a perpendicular, okay, and make another little baby right triangle. Okay, this one has a leg of 1 and a leg of 4. Holy crap, it's the same triangle. So if we did the math on this, we'd get the same thing. So we're not going to do the math again. We're just going to write square root of 17 because we're smart like that. Now, because those two sides have the same measure, we can mark them as congruent. Okay, let's find some other lengths. This big old base right here is 1, 2, 3, 4, 5, 6, 7, 8 units long. Okay, the base on the top is 1, 2, 3, 4, 5, 6 units long. Well, shoot, now I got all the sides, we can find the perimeter. So my perimeter is 6 plus 8 plus, I have a root 17 plus another root 17. Well, 6 plus 8 is 14. And I have 2 root 17s. I have 2 of them. So I have 2 times the square root of 17 units. That's my perimeter. You can write yours on the line, but I'm not going to scroll back and forth because that made me crazy today. All right, area. Now, watch this. Watch what I do here. Oops. Okay. So let's say I have a figure like this, which is kind of like this figure. Okay, what I can do is perform a little piece of surgery. I'm going to chop off this little triangle, and I'm going to take this little triangle and put him up here. So he's gone there. Now he's there. You see how I'm making a rectangle right now? I'm going to chop off this little triangle, and I'm going to put him up here. Now he's gone. So what I've made here is a little triangle, and it has a height, and it has a base. Now the base is not this length or this length. What it is the average of those two lengths. Okay, so it's halfway in between them. So for instance, if this one was 6 and this one was 8, then my base for the rectangle that I made would be 7, because 7 is halfway in between 6 and 8. That's what we're going to do for this little trapezoid. This is a trapezoid, by the way. That's where the area formula for a trapezoid comes from. The area for a trapezoid is 1/2 of your first base plus your second base. Okay, that's just the formula for an average. It says add them together and divide by 2. 6 plus 8 is 14. 14 divided by 2 is 7. Right? So we average the bases and then we multiply by the height because that's the equivalent little rectangle. All right, so let's plug our stuff in. So my area is 1/2 times my 6 plus my 8 times my height. My height is 4. Okay. 6 plus 8 is 14. 1/2 of 14 is 7. 7 times 4 is 28. So my area is 28 square units. Okay, so we already said that this was a trapezoid, right? But this is not, and we can tell it's a trapezoid because we have opposite sides that are parallel. Those sides both have a slope of 0, so they have to be parallel. That's what makes it a trapezoid. Now, this is not just any trapezoid because in addition to having parallel sides, we also have a pair of congruent sides. Remember, we said those were the same. So this is what we call an isosceles trapezoid. Isosceles trapezoid. Okay, that's its classification. Okay, we have to find the perimeter and area and classify. Okay, we're going to keep using the same method because it's working great. We're going to keep making little baby triangles. All right, look at this. Look at this little guy. Pew, pew, pew. We made a little right triangle right there. So this triangle has one leg of 3 and one leg of 4. So we're going to use our Pythagorean theorem. 3 squared plus 4 squared equals c squared. 3 squared is 9. 4 squared is 16. Okay, 9 and 16 are 25. Okay, we have to take the square root to undo the squaring. We have two solutions, positive and negative. We want the positive one, so 5 is our c value. Now, if you look at the little triangle that we can make over here, my little red one, it also has a leg of 3 and a leg of 4, so it has to be 5 also. Okay, now let's count some easy blocks. We went for the hard ones right out of the gate. So if I count 1, 2, 3, 4, 5, I can see that this whole side is 5. And 1, 2, 3, 4, 5, I can see that that whole side is 5. So my perimeter is 5 plus 5 plus 5 plus 5. My perimeter is 20 units. Now, before we can find the area of this guy, we need to classify him because the area formulas depend on what the classifications are. You know what I mean? Like the last one, we had to say it was a trapezoid before we could use the trapezoid formula. So what's special about this is that it has, let's talk about its sides and their slopes really quick. Okay, so do you see these two horizontal sides, the ones that we counted in pink? These both have a slope of 0, m equals 0, m equals 0, so they have to be parallel. I'm going to redraw my picture down here, guys. Okay, so this side has to be parallel to that side. Sorry my picture sucks, but you get the idea. I don't want to gross up my picture anymore. All right, so if you look at my little slope triangles, I can see that for this side, it's rising 4 and running 3. So this side has an m of 4 thirds. Okay. Over here in the red, this side rises 4 and runs 3. So this one has an m of 4 thirds. So these two sides are also parallel. What I have here is a parallelogram, and it's not just any parallelogram. It's a parallelogram where all 4 sides are congruent. Okay, this bad boy is a rhombus. He's a rhombus. So if all opposite sides are parallel, and all sides are congruent, you have a rhombus. Okay, now that we know he's a rhombus, we can find his area. So the area of any parallelogram is just base times height. So area equals base times height. So I have a base of 5 and a height of 4, because remember that the height has to be perpendicular to the base. So that's just 5 times 4. So my area equals 20 units squared. Okay, let's keep it moving. I don't know about you, but this kind of looks like every rectangle I've ever seen in my life. And it is. It's a rectangle, but we're going to talk a little bit about why it has to be a rectangle and how to prove it. Because you can't just say, oh, I eyeballed it on your test. That's not going to fly. You won't get points for that. So let's talk about the perimeter first. This is easy because we don't have to do any distance formulas. We just get to count boxes. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay. My perimeter is 8 plus 8 plus 6 plus 6. I'm getting 28 units. Okay. Now, let's talk about why this has to be a rectangle. Okay, so first of all, in a rectangle, we know that opposite sides are congruent. And these sides have the same measure, so they're congruent. And these sides have the same measure, so they're congruent. So for a rectangle, we need opposite sides congruent. Also, we need opposite sides parallel. Okay, so far, this is exactly like a parallelogram because a rectangle is a special type of parallelogram. What distinguishes a these are both vertical, these are both horizontal, so we have opposite sides parallel, check, opposite sides congruent, check. Okay, what distinguishes this from a regular parallelogram is that our consecutive sides are also perpendicular. Okay, this is a big one. Okay, a consecutive side is not like opposite sides. Like the 6 and the 8 would be consecutive sides. Not the 6 and the 8. Those are the actual lengths. What I'm trying to say is this side that measures 6 and this side that measures 8 are consecutive sides. That's what I meant. And for a rectangle, consecutive sides must be perpendicular. And these are because I've got horizontal, vertical, horizontal, vertical. And horizontal and vertical we know are perpendicular. So this guy is a rectangle. He's also a parallelogram, but rectangle is a more accurate name. It's a more specific name. Okay, so now that he's a rectangle, we can just say, okay, length times width, base times height. Area equals 6 times 8. That is 48 units squared. So all of this is true for a rectangle. Okay. All right, let's do our little trick again. Let's just keep making little, whatchamacallits, triangles. Okay, let's go outside the figure for once. Okay, so this little side is 3, this little side is 4. Didn't we already do this with a 3 and a 4? If you look back in your notes, we did a 3, 4. A 3-leg, 4-leg has a hypotenuse of 5. We're not going to do that again. We can go back and use our previous work. That's what's called as a 3, 4, 5 right triangle. The sooner you learn that, the happier life will be. So if I look at this guy, pew, pew, I have another 3, 4, 5 right triangle. If I look over here, pew, pew, I have another 3, 4, 5 right triangle. Okay, if I look here, pew, pew, I have another 3, 4, 5 right triangle. Here's my right angle. Sorry, I got a little sloppy. All right, I've got a perimeter of 5 plus 5 plus 5, all fives. 5 plus 5 plus 5 plus 5 equals 20 units for my perimeter. All right, now in order to find the area, I need to know what kind of figure this is. Okay, so we're going to do a little bit of investigating about the slope of the sides, because right now, with all the sides congruent, this could either be a rhombus or more specifically, it could possibly be a square. So it's definitely a rhombus because we have all sides congruent. But if the opposite sides, wait a minute, if consecutive sides are perpendicular, like a rectangle, then it's a rhombus and a rectangle, so it's a square. So we have to check for perpendicular. Let's go. So the slope for this side is up 4, right 3. Now we need this slope here to be down 3, right 4, which it is. You can see that it's going down 3, right 4. Okay, these are opposite reciprocals. So those sides are perpendicular. I'm going to say consecutive sides. Okay, so let's check some more sides. This little guy goes up 4, right 3. So this segment has a slope of 4/3. So these are opposite reciprocals. So far, so good. This one goes down 3, right 4. So let me do that in another color. This one here is -3/4. And you can see as we go around the sides, they're all opposite reciprocals when you look at the consecutive side pairs. So this is a special rhombus that is also a rectangle. We know that he's a square. Okay, so we need, for a square, consecutive sides are perpendicular, check, and we need all sides congruent. All sides congruent. Check. That's for a square. So now the area is just really simple. It's just his side squared. So our area is just 5 squared, which is 25 units squared. Okay, so the area of a circle is pi r squared, where r is the radius. The radius is the distance from the center to the edge. Okay, so the circumference is 2 times pi times r. We're going to use this one more often. The diameter, guys, is just twice the radius. Or, if you rather, the radius is half of the diameter. Those two things are the same. Okay, so if you look at this guy, they're telling you our entire diameter is 6. The diameter goes from edge to circle of edge to circle, passing through the center. Okay, that's important. It has to go through the center. Okay, so if our diameter is 6, then our radius is half of that. So we go from the center to the edge, that's our R, and our R is 3. So now we can find the area and the circumference. So the area is pi times our R squared. So our R is 3, and we have to square the 3. Well, 3 squared is 9, so our area is 9 pi. Okay, our circumference is 2 pi r, and our r is still 3. So 2 times 3 is 6. So our circumference, whoa, let's go back. I forgot to say units squared. Sorry. Area is units squared, always. Shame on me. Okay, so our circumference is in linear units. It's like the perimeter. It's the perimeter of a circle. So our circumference is 6 pi. All right, let's try another one. Okay, here we're given from the center to the edge is 4. So that's our R. So our area equals pi times our R squared. So 4 squared. 4 squared is 16. So our area equals 16 pi units squared. Okay, our circumference is 2 pi r. They told us the r is 4. 2 times 4 is 8. So our circumference is 8 pi units. All right, that's it, guys. We made it.